China is building nuclear reactors at a pace the US hasn't touched in 50 years. But here's the part most people miss. It does not matter who builds the smarter AI. If the US does not fix its power problem, China wins by default, because their models will simply have more electricity to run on. This isn't a race about chips anymore, not really. It is a race about who can keep the lights on long enough to win. And right now, Washington is still filling out permit forms while Beijing is already building.
The Biden administration and EPA are proposing new regulations for coal and gas-fired power plants.
Outside Richmond, Virginia today, one single building pulls more power off the grid than every home, store, and hospital in that city combined. The grid operator there already issued a blunt warning: stop adding data centers, or the power fails for everyone else nearby.
Is America's electric grid ready for the AI boom? Well, there are those who debate it and there are those who study it.
A single AI campus can draw as much electricity as a small country, and China is building the infrastructure to run dozens of them, while America argues about where to put one. So forget who writes the best code. The real war is over who controls the power grid that code depends on, and China is building that grid faster than the US can approve the paperwork to start one.
If the only determinant were the availability and cost of energy, China will be winning that race.
In this video, you will see exactly how China is outbuilding the US, why Washington's hands are tied, and who really controls the fuel that runs the AI race. Act 1. The hidden bottleneck. For the last 2 years, everyone told you the AI race was about chips. NVIDIA, TSMC, export controls, who gets the best GPUs. That was true in 2023, it's not true anymore. The real constraint on how fast any company or any country can grow its AI capacity now comes down to one thing: megawatts, not chips. And both Washington and Beijing already know it, which is why this fight moved from the semiconductor lab to the power plant.
Focusing on chip makers and AI developers is futile without a way to supply power.
Here is the chain, and it is worth walking through because every part depends on the last one. Start with AI models. They need chips to run. Those chips need data centers to hold them. And those data centers need power, a lot of it, running continuously. That power needs a grid to carry it and a fuel source to generate it. Break any link in that chain, and it does not matter how good your model is. It just sits there, starved. Here's the scale of the problem in the US. Grid operators and the Department of Energy have projected that data center power demand could double, maybe triple, within the next few years. Translate that into plain English. The US grid was built to handle a certain load, and in less than a decade, it may need to carry 2 to 3 times that just to keep AI running. That is not a small upgrade. That is closer to rebuilding a chunk of the national grid while it is still switched on. And this is where the US and China start from very different positions. The American grid is old, some of it built in the 1960s and 1970s, and getting a new transmission line approved can take a decade once you count permitting, environmental review, and local opposition from communities that do not want new lines running through their backyard. China does not have that problem. Beijing can approve a gigawatt power plant and connect it to the national grid in a fraction of the time it takes the US just to finish paperwork. That gap is why both countries are now racing toward the same target: nuclear power. Not because nuclear is trendy, but because it is the only major power source stable enough to run a data center 24/7 without interruption. Solar drops at night. Wind drops when the air is still. Nuclear does not care. It just runs. But here's the part most people miss. China is not just building more power than the US. It is building a different kind of energy strategy altogether. One that treats power the way you would treat a national security asset instead of a utility bill. What that difference actually looks like and what it means for who wins this race is what the rest of this video is about. So now look at what each side is actually doing to win this. Act 2. The build-out race. Start with the US approach because it tells you everything about how urgent this shortage already is. Microsoft, Amazon, Google, and Meta aren't waiting on the government to fix the grid. They are going around it, signing direct deals with nuclear plant operators to lock down power output for themselves, and in some cases, to bring dead reactors back to life. The clearest example is 3 Mile Island. That plant, the same one tied to the 1979 partial meltdown that became a household name for nuclear disaster, was fully decommissioned, shut down, not producing a single watt. And now it is being restarted not to power homes in Pennsylvania, but under a deal to feed a data center. Think about what that means. A company looked at America's aging nuclear fleet and decided that reviving a plant people spent decades trying to forget was still faster than building something new. That is not a sign of confidence in the system. That is a sign of how bad the shortage already is. And that points to the bottleneck inside the bottleneck. Building a new nuclear plant in the US does not take a year or two. It takes a decade or more once you count permitting, safety review, and construction. So tech companies are chasing a shortcut. Small modular reactors, or SMRs, smaller nuclear units that are supposed to be faster and cheaper to build than a traditional plant. The problem is, SMRs are still mostly unproven at commercial scale. Nobody is running a fleet of them yet. So the US is betting a chunk of its AI power future on a technology that has not fully left the lab. Now look at China's approach, and the contrast could not be starker. China is running a state-directed build-out of new nuclear reactors at a pace nothing in the US can match. And it is backed by a single national grid operator instead of dozens of private utilities, each fighting their own state regulators. Here is the number that matters. China currently has more nuclear reactors under construction than the rest of the world combined. Translate that 5 years forward. While American tech giants are still negotiating deals to revive plants from the 1970s, China could be bringing a wave of brand new reactors online, all feeding a grid that is already built to carry the extra load. Why does China's model move faster? Not because their engineers are better. It is the system underneath. No shareholder votes to slow down a project. No competing state regulators arguing over jurisdiction. No local opposition strong enough to stop a plant. Once Beijing decides it is getting built, the state picks the site, the state approves the plant, and the grid gets built on schedule. That is the choke point in action. Whoever controls the approval process controls the timeline. And whoever controls the timeline controls how fast their AI industry can grow. And China is not betting everything on nuclear alone. It is building coal plants at scale too, as a backup baseline that can run when demand spikes, while also pushing renewables harder than almost any country on Earth. That is not indecision. That is hedging every energy bet at once, so no single failure point can stall the build-out. Step back and look at what this actually is. This is not just an energy story anymore. It is a rerun of the Cold War industrial race, except the factory floor is a power substation, and the product rolling off the line is machine intelligence instead of steel or missiles. But building power at home only gets you half the story, because a reactor is worthless without fuel, and that is where the real fight is hiding. Act 3, the resource, chokehold. A reactor without fuel is just an expensive building, and the fuel that runs it, enriched uranium, is where the US has a problem nobody is talking about. For decades, America outsourced its enrichment capacity instead of building it at home. It was cheaper to buy the fuel than make it, and a real share of that supply chain runs straight through Russia. Sit with that for a second. The same country that has been sanctioned, cut off from SWIFT, treated as a strategic threat in every other part of US policy, still supplies a meaningful chunk of the enriched uranium that keeps American reactors running. That is not a footnote. That is a country trying to win an AI power race while depending on a rival to fuel the reactors that race needs. China made sure it never had that problem. Beijing has spent years locking down uranium supply deals across Africa and Central Asia, and building enrichment capacity at home instead of renting it from someone else. China treats fuel security exactly the way it treats oil security. Something you own, not something you rent. Oil once decided who had leverage over the global economy. Whoever controlled the flow of oil controlled the terms everyone else had to accept. Uranium is becoming that same leverage point for the AI economy, and so is raw grid capacity. Different resource, same mechanism. Here is the verdict. Whoever locks down stable, scalable power first does not just win a domestic race to build better AI. They set the terms for every other country that has to plug into their systems, buy their compute, or run on their models. Power is becoming the new form of leverage, and right now, one side is buying fuel from a rival, and the other side owns the whole chain. That is the real battle hiding under every AI headline you have read this year. The AI race won't be settled in a chip lab. It will be decided at a power substation no one is watching, by whoever gets the megawatts flowing first. Code you can replace, power you cannot. If this helped you see what's really going on behind the AI headlines, subscribe and share it with someone who still thinks this story is just about chips.